Welcome, everyone. This is graphs of cosecant and secant. Before we go ahead and graph it like we do with sine, cosine, and tangent and cotangent, what I wanted to do is review what cosecant is. What do you guys know about cosecant? It's the reciprocal of sine, right? So it's 1 over sine, correct? Yeah. If you think back to where we started, the first day we started trig, sine of x or sine of whatever angle it is equals opposite over hypotenuse, right? And cosecant of x then is going to be hypotenuse over opposite, correct? Yeah. Same thing with cosine and secant, right? It's adjacent over hypotenuse and then hypotenuse over adjacent, right? Okay. So based off of the fact that sine and cosecant are reciprocals and cosine and secant are reciprocals, in order for me to graph cosecant, let's say, first, I'm going to graph in pencil. I'm going to first graph sine of x. Okay. I'm going to first graph that. So I am going to go ahead and label out my x-axis, pi over 2, pi, 3 pi over 2, and 2 pi, right? And remember, graphing sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is -1. This is the incorrect labeling. This should be -1. And then sine of 2 pi is 0, right? So I have that here. And I am going to dot it, right? Dash lines or dashed curves, because that's not the real curve that I'm interested in. Okay? All right. What now if I'm graphing cosecant, right? Cosecant of x, and we just talked about how they're the reciprocals. What is the reciprocal of 0? The reciprocal of 0 over 1, it's going to be 1 over 0, right? Which equals, what is 1 over 0 then? It's undefined. Okay? And remember, whenever there is something undefined, we put a vertical asymptote on it. Okay? So all these zeros are my vertical asymptotes. Okay? So I'm going to go ahead and put a dashed vertical line on 0, on pi, and on 2 pi. Okay? Make sense? Yeah. The reciprocal of 0 is undefined. Okay? Now, what is the reciprocal of 1? Because that's my next point here. 1, right? The reciprocal of 1 is 1. What's the reciprocal of -1? -1, right? If you flip 1 or flip -1, 1 over 1, if you flip that, that'll just be 1 over 1, which is 1. -1 over 1 If you flip that 1 over -1, which would also be -1, right? So those 2 points exist on my cosecant graph, okay? And what we're gonna do here and here, these you guys can treat as my vertex of the parabola. The parabola will go away from the sine graph towards my asymptotes. Away from the sine graph and towards my asymptotes. And that is the cosecant graph, okay? You guys can go ahead and you guys want to erase the sine function here, right? Because those are just my guidelines. And that would be my cosecant graph, okay? All right, we're gonna do the same thing for secant and cosine. Same exact thing, okay? First, in pencil, well, not in pencil. So I have to label my my x-axis. Okay. And then in pencil, cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0. Cosine of 2 pi is 1. Right? So I have this cosine function. Right? And again, the reciprocal of 0 is undefined. So whenever cosine is 0, I'm going to put up a vertical asymptote. Cosine is 0, put up a vertical asymptote. Okay? Reciprocal of 1 and reciprocals of -1, right? They all exist. But notice now in one period of cosine, right? There's only 2 asymptotes for secant. And I don't have the other asymptote here, right? In my -pi/2. So here, I'm just gonna go one side of my parabola towards my asymptote, okay? Here, I can go both sides because both asymptotes are represented. And at 2 pi, I'm just gonna go here. Easy enough? Yeah? So class, your first step in graphing cosecant and secant, right? If I give you, let's just talk about it first. Okay, if I give you something like y equals 3 cosecant of x minus pi plus 2, right? Okay, if we have to graph that, what the first step would be is to first graph 3 sine of x. Okay? Graph this guy first, 3 sine of x.